Okay, Paul here, and today on the bench we have an unknown radio. Um, and we're going to try to figure out what's going on with it. It's got the bakelite case, and it's got a few little imperfections. There's a crack here. Part of the bottom of the on and off switch there is cracked. It looks like somebody put on a new speaker grill, and they put on this new cloth line cable without a plug. So that's a strange one. The case overall looks pretty good. Nice brown textured case. Looks like tiger wood almost. It's really nice. Volume controls here, and has increased that way, which is interesting. Nice gold brass sconce there. And this is the tuning capacitor, or as they call it, the station selector. And it's just numbers 0, 10, 20, 30, 40, 50, all the way up to 100. That's strange. Yet haven't been in it, don't know anything about it. The back bottom has a little piece broken off here. You can see that's not closed good. Somebody has definitely been in here because, like I said, that's new. There's an antenna line that looks new as well, or replaced not that long back. Actually, there's an extra wire here. Unless it's, oh no, they just twisted two wires together. Okay. Yeah, it looks like it was, like they cracked it here when they didn't adjust this screw correctly. I don't know, but, or maybe it just got dropped there and tapped. It's all slotted screws, and they're well rusted, but that's okay. So we're going to open it up. Here's the sides. We're going to open it up and see if we can find a chassis number on it to pull out a schematic. It's pretty heavy. It's really neat with these screws, the way they're set up. The controls have set screws, so might as well go ahead and take them off first. And that goes from 0 to past the 100 all the way down to the L and select. Actually, no, it's loose. Take that back. That ain't even connected. Okay, and this one is. It goes to there and to the just above the V, but it feels loose too. Yes, it's loose too. So we'll take it off. And check that out. Ah, there's a crack right through this one here. You can see it's cracked there. You can see that. So it's cracked right where that screw is. Apparently they tried to overdrive the screw. And we will try to see if we can free that up. Oh, it's in bad shape. I don't know if I can even free that up. Actually, that don't even look like a screw. That looks like somebody put something in there and made a slot in it. No, it's got to be a screw, but it's a screw. But it's well in there, and the knob is cracked. So we got to be very gentle with that and try to get that screw out of there. Let's see if we can get it loosened. No, it's not. The screw is actually busted. How do you like that? It broke right through the top of the screw. See how I don't know if you can see that, but the screw itself is busted, and then the knob is split through there. Okay, that's what we're dealing with. Is just, oops, sorry about that. What we're dealing with there is just normal wear and tear on these bakelite pots. And this one we may have to, I don't know how we'll fix that yet, but I'll be thinking about it. I know I want to glue it, but I don't know how we're going to get it to get tight on there. Might have to try to find another one of those knobs. I don't know that that's even possible. All right, it's got screws in the back and 2 here. Let's take out 3. 1, 2, 3. Let's take out the back screws first and see what we got when we take the back cover off. Okay. And I moved my camera to another position. I'm always playing around with my camera, try to see if we can get a better angle where you guys can see better. Okay, that came out. That's nice. Take a look at these screws. It's interesting. They're 1/2 inch, look like number 6 beveled screws, slotted. I apologize for the noise in the background. That's my heater. It's a little bit cold because of the chilly rain we're having, but I think I can lower that. Okay, that should be a little better. Okay, let's see how that comes off. Okay, and the cord goes through there. Yeah, there's some issues here, I'm sure. Okay, let's pass that through there gently. Okay, and there's the back, and we have license only for radio amateur, experimental, and broadcast reception under the following patents of RCA and associated companies. So we know it's an RCA chassis, and it's interesting, it was licensed for radio amateur experimental. So experimental. So apparently it was released for, judging by those patent numbers, we're talking, well, the highest one is 1.8 million. We're looking at something from the 30s, perhaps 40s. But it was licensed by RCA. It says, and further licensed under patent application covering operation on AC or DC, so it's an AC-DC radio. The manufacture and or sale of this apparatus does not imply any license under any patent related to the structure or manufacture of the radio tubes. Okay, so the tubes are not part of the actual license agreement. What is that? Speed. I've never seen an embossed label on a tube before. That's interesting. This is a 36 here. There's a rectifier, and I don't know that that rectifier is any good. Looking at it, I'm a little bit concerned about that. Okay, so anyway, we'll set this aside gently and continue looking at what we got here. Well, it looks like a radio that has a 1500 ohm power resistor across the back, which is good, because the alternative back then would have been that it would have been a 3-wire line, and one of the wires, or a 2-wire line, and one of the wires would have been a resistive wire for, actually 3 wires, resistor wire for the filaments. But this one, like another one I've been working on recently, has a most likely 1500 ohm power resistor that goes across the back here that radiates heat, and that's what this metal's for and what this screen is for. It's to radiate the heat dropped on this so that it can, because the filaments do not add up to 115 volts. Okay, so let's keep the light up here where maybe you can see better. All right, so we'll get it out of the chassis and take another look at it. Like I'm saying, that rectifier tube don't look too great, but I'm looking at the little attachment wires there that a lot of times get blown off the rectifier, off the cathode, but they seem to be intact, so we may be all right there. The customer who owns this radio says he has not tested it, obviously, because he got it when it had no line cord. Let's go ahead and take these screws out of the front so we can get the cabinet to drop out. And I'm going to leave the screws loose till I see how much pressure's on. Well, I think it's okay. It doesn't seem like it's dropping back there. No. Okay, we're all right. I just like to be gentle when I'm taking the screws out and the radio is facing up in the air, but this is fine. I got a very good padded bench for that very reason. Most people would not put a padded carpeting on their bench, but I'm not most people. Okay, we'll gently raise that off, and voila, wow. I have never ever seen a radio that had an electromagnet inside the cone on the front of the radio, of the speaker. And this is the actual voice coil setup. Somebody's been in here. And there's a pin that moves up and down that moves the cone. Usually they're from underneath. This one is got the magnet in the cone. Very interesting. And somebody's been in here. You see these wires are just taped with electrical tape. They don't have shrink wrap on them. I don't know what they're for. Don't know what they did. Oh boy. Okay, what do we have here before I go too far? Okay, that's the wire. They did put some shrink wrap on that. Interesting, but they didn't cover all of the braid on the wire. It has a felt surround going around the speaker cone. I've never seen nothing like that. That is weird. Dog bone resistors, mica caps. It has some 200 volt electrolytics tied together in parallel. It looks like, well, no, these are the grounds, and those are the anodes. Okay, let's take a look at the tube complement here. We have this speed tube, interesting, 36, and that looks probably like a 38, yeah, 38, that's the audio output tube, and so this is the oscillator mixer, this is the detector, and then rectifier and the audio output. Don't know what that tube is. 36, 38, it's probably a 39. Very interesting. Well, I know one thing, if we power this up, we're going to bring it up on a variac for sure. These wires are going to the power switch, which is sluggish. Do you hear that? Listen. That's not doing it now. Okay, it's doing better now. When I first was turning it on, it would take a half a second before it would click, which meant that the switch was sticking. There's a loose nut on it. Okay, well that's tighter. But that's okay, we can spray some cleaner in there and get that working better. Oh, this is all chewed around here where that screw was not turning earlier. It's turning freely though, and the potentiometer is turning good. Okay. The question is, did they wire this correctly? Oh, look at that. Wow. I don't know if you can see that. Let me turn it around here. The people who put this, let me get that cord out of there. People who put this line cord in connected it right here, which is probably where the old cord connected, but look at how close that is to that side. I guess that's okay. It just makes me nervous. You go to take this out of the chassis and look at it or anything. Well, for one thing, it's probably a hot chassis, but you come across those two very easy with them being right like that. Okay, so they've got a line coming here which goes to these this capacitor, and then goes to, I guess that would be the common. Yeah, that's the common there. These capacitors, they're empty. There's nothing left in those. And that funky thing, that's a coil wrapped around, I don't know, it's probably just a coil, a choke coil. And we got a box capacitor down there, which is another electrolytic. And boy, they're going to be fun. Just looking for anything that looks strange. That looks kind of strange, but I guess that's okay. That terminal's right up against that mica cap. This looks suspicious, but it's soldered okay. So I don't see anything that was done other than somebody started to put a line cord in here. And they got it going. They got to go into the resistor, which comes over to here. This coil's got some damage to it. No, that's not good. One, you can see it got hot, and two, you can see it smashed here and has the coils have been pushed aside. Now, the reason that got hot is probably the capacitor that they used to install capacitors inside the coils when they made a tank circuit like that. And I'm looking in there, and sure enough, I see something that could be a capacitor. The actual heating element of this 1500 ohm resistor, the terminal is going right inside the coil. That's a lot of heat there, and especially on this wire. But it might be all right. I'm not sure. That wire might have got pretty hot up against that asbestos there on the back of that resistor. So that's just a strange chassis. kind of weird solder joint there that peeled free from the resistor. It looks like this screen here was soldered there, and it just came loose. This one fell completely off. That one's partially there. This one's partially there, and this one's half broken off. I'm just pointing out things I see because this helps me as I go through to understand what's going on. And we have a capacitor in that coil as well. You can see it there. See the capacitor there? I'm going to put a little light in there. Maybe you can't see it at that angle. But in that, yeah, you can see that. Okay, so that's what they did, is they put those microcapacitors inside the coils when they're making a tuned radio, tuned frequency radio, and that's what this is. It's a tuned frequency radio. The next thing I need to look for is anything connecting to ground. Well, it looks like the tuning condenser is connected to the chassis. Oh, look at this. Another two filter capacitors there. So we got two here, two underneath. And we got a big old hole in the speaker, but that looks like factory. That is so weird. See my hand through the speaker there? There's actually a cutout of the cone so that they could get the volume control in. And the volume control goes right through the cone. This is the strangest setup I've ever seen. You see why I want to find I'm going to stand it this way because it's the safest way to stand it when I'm looking at the bottom and the side. Why I want to find a schematic is what I started to say. I want to make sure this is right. It looks like this was probably correct, but I don't know why they would have not put the plug on or cut that off. Well, I guess the starting point would be take some resistance readings, take some continuity checks. Let's see. I'm gonna assume, and I don't like to assume, but I'm gonna assume that this is common since these capacitors are stuck together there. So I'm going to put the ohm meter across that. Okay, let's check some continuity. First, let's see if there's anything going through this cord. No. Put the switch on. Okay, there's nothing going through the cord. So that's okay because it's an AM AC/DC radio, and they probably just don't have the power cord connected to the common directly. It's probably going through a high resistor or a capacitor, but I'm not getting nothing through it. Interesting. No resistance at all. Okay. Now, let's see here. Nothing. Let's try the other end of that capacitor. Not even getting. I'm getting high end resistance to that. That's interesting. And the switch is on that side of the cone. I don't want to mess with that. Let's see what we can get here. Okay, we got some continuity there to this side of the coil. And it appears that the coil is good if we're going through just the coil. Okay, that has two wires going to the capacitor, tuning capacitor, actually going to this coil here. Okay, so those coils appear to be good. This one I'm still not exactly sure because it got so hot. Let's check the transformer. Well, we got a resistance across that of 500 ohms, 460. That could be through the tube. Check that rectifier tube. Yeah, I think this rectifier tube has bit the dust. You see that stain there, and maybe not. Who knows? It looks like it got hot and pitted in there, but it's hard to say. It's a 4-pin tube. I have to pull the spec up on this if I can find a number on it. I'm not finding it. Yeah, I think this rectifier is dead. Not getting no continuity across what should be a filament. I'd say it's dead. See how hot that side of the anode got? This thing has seen some heat. So, yeah, it just says rectifier. It don't even say what tube number it is. Let me see. Should only fit in one way. It fits in that way. Fits in that way, almost. There it is. Okay, it only fits in one way. Gently take this one out. Is the cap loose? Yeah. And it says that it's a 38, which is pretty much what I figured. Okay, 38, 36, those are 5-pin tubes. Those are pretty standard. That's that one. You got to be careful when you're checking these, because sometimes the grid caps come loose on these tubes, And so you really got to be careful. And this one being in this shielded case, yeah, it's a 36. I don't have a tube tester that tests these antique tubes. These tubes are really old. So the best I'll be able to do is check the filament string to see if they have damage to the filament lines. But they look okay. That one, the rectifier, I don't know. And it may be that it's just a high resistance on the filament, but I don't think it'd be that high. Let's see what this guy is. Enclose that tuning capacitor. That's a 39, that's what I figured. Yeah, that's 39. It's hard to see in this one. It's got a lot of silver. Okay. I'll definitely clean that out later. Okay. Well, I don't know why we're not getting no continuity across that line cord. That is so weird. Let me try it again. Maybe if I clip my probes directly across the line cord here. Okay. Right. Nothing across the power, so it's probably just capacitor. Wow. To be honest, I don't even know where to begin with this thing without a schematic diagram, and I don't even know if I can find one. I don't see no chassis number on this. Yeah, magnet wire here. And it looks like it even has a buck coil on it. Interesting. It's got some kind of tuner on the speaker too. That's the speaker wire. Comes over to there, to the amplifier. That's pretty accurate. Should be 2 meg ohm. 5 zeros. 2050. That should be 2 meg. Well, it isn't accurate. It's pretty high. What about this? Brown, black, green. That would be 1 meg ohm. 1.7. So a little better than that one. And that one I can't make out with. Oh, black. Okay. 5, 0. And that looks like orange, which would be 500K. 50K, that's right, 50K. I'm going to stop this for a while. This is correct, going to this, I'm not sure what this is all about here, but it's going, it's probably okay too. I need to find a schematic on this. I need to find out what chassis this is.